In this lesson, we will cover different data analysis approaches with special focus on user-generated content in the context of creative industries. In particular, we will discuss the various types of user-generated content and the types of analysis that can be applied. First of all, we define the concept of user-generated content. That is, all the content that users in the consumer category produce on digital platforms. This content can be in text format, images, and videos. We also include the relationships and interactions that are created between people within social networks. Such content evolves over time and often also have geographical relevance. Therefore, it's interesting to study them also according to these dimensions. A good data analyst is able to understand the problems, find the right questions to ask, and apply the appropriate techniques to answer the questions. These analyses along time and space are frequently combined together. For instance, you must combine time and geolocation of events. Considering the problems of data integration and heterogeneity of the scales, you can use grid-like strategies. You obtain events that are located in time and space within grids and cells. Your analysis then implements a sliding window looking over reality. All this can be encoded in a conceptual model like this, which represents all relevant dimensions and entities in the analysis. The spatial aspects like place, cell, grid are shown in green, and the temporal aspects like events, pixels, frames that represents the evolution of the grid in time are represented in blue. Furthermore, you should also integrate the actual content related to these dimensions, in red here, with metadata describing the provenance of the data itself, in yellow. Besides time and space, a lot of effort must be devoted to analyze the content itself. Two most important categories of machine learning problems are classification and clustering. Classification aims at categorizing items into a set of classes that are defined in advance by a domain expert. The expert also provides examples of items in each category, so this is a typical supervised approach. For instance, a possible task is to classify newspaper articles as politics, sport, or local news. Clustering instead aims at grouping items by similarity, without any information about predefined classes. The method is unsupervised because it autonomously looks into the data and clusters them just based on the available values. For instance, we may want to group together users that behave similarly. Regarding textual content, there are various analysis techniques that go under the name of natural language processing, NLP for short, and that deal with the level of syntactic analysis of the text. They are followed by higher-level techniques like named entity recognition, topic analysis, sentiment analysis that extract latent features from text. Additional techniques, known as vector embeddings, perform transformations from text into vector format, so that machine learning solutions can be applied. The most recent solutions, implemented by Google and other AI big players, define the concept of language model, built over enormous quantities of text. Let's now consider in details some of these techniques. Named entity recognition aims at identifying, extracting, and categorizing elements in the text that correspond to real-world entities like companies, people, locations, or numerical concepts. For instance, in this sentence, we can identify Thomas as a person, 5 as a quantity, Apple as an organization, and 2019 as a temporal value. Topic analysis uses probabilistic techniques like latent Dirichlet allocation. In this approach, every document is assigned to a set of topics, with the probability of belonging to each topic. This is very useful for categorizing documents. If the topics extracted from the method are too many, you can always keep only the most probable ones. Sentiment analysis focuses on detecting the attitudes of a person, the source, towards a given object, the target, based on a text provided as input. We can run a refined analysis trying to understand the affective state, like love, hate, desire, and so on, or we can simply try to provide a numerical weight. The most common way to do so is through a triangular model that weights two dimensions: subjectivity and polarity. Subjectivity specifies whether a text is objective or subjective. Polarity defines how much positive or negative is the sentiment. The model is represented as a triangle for this reason. If the content is completely objective, there is no space for polarity. If it's subjective, it can be positive, negative, or neutral. As far as images are concerned, deep learning techniques are currently able to solve problems such as object recognition, image classification, segmentation, face detection and characterization, and other complex tasks, starting from low-level features of the images themselves. The most used techniques on image is called convolutional neural network. The analysis in the temporal dimension is covered with time series analysis, recurrent neural network, that are neural networks that learn continuously with the progress of time, and further advanced methods. In particular, time series analysis envisages breaking down the data into four fundamental components: trend, seasonality, cyclicity, and a random component. The trend component represents the long-term evolution of the signal in time. It is used to recognize persistent evolution in the data, which in practice consists typically in an upward or downward trend. The seasonal component represents regular up and down patterns in the data that repeat themselves in short-term intervals. Typically, this happens on daily, weekly, monthly, or quarterly basis. The cyclical component is again a repetitive wave pattern with longer-term dynamics and sometimes lower regularity. Finally, the random or residual fluctuations are the rest of the signal, obtained by removing all the other components. This is the hardest part to understand and estimate. The last type of content we consider is represented by network structure. This is a very important data model today, as it can represent a huge set of possible contexts, including social networks, connections between objects, like product, documents, and so on, and many others, like activity of users, or even road networks in maps. The typical problems we face here are node classification, link prediction, community detection, network similarity, and others. For instance, node classification is the task aiming at deciding to what class a node belongs to. For instance, if the network represents people and their relations, we may know the sex of some people and not of others, so we want to automatically classify the remaining ones. Link prediction instead focuses on the connections between nodes. In particular, it wonders whether two nodes are connected together or not. This is a prominent problem in social media, for instance, because it allows to predict if two people become friends or not, or if a person is going to like a given post or video. This is actually how platforms like Facebook, LinkedIn, Pinterest, or Instagram suggest friendships or propose recommended content to users. All these analyses are today customary in many fields. Companies that are able to collect good quality data and run appropriate analysis are able to extract valuable insights for innovation or optimization of their business. This happens at any stage of the value chain, including product definition, event management, people organization, communication and marketing.